Okay, so we've done a couple of examples in 2.6 with how to use these quadratic functions to solve word problems. And at the beginning of this lesson, on the first page, at the top, it outlines for you the steps that you should take. First of all, you have to make expressions for your unknowns. Then you have to construct the quadratic function. And since it's a maximum or minimum word problem, that means you're dealing with the vertex, specifically the x vertex, which will get you one of your answers for one of your unknowns. And then you just plug that answer in to find the other or others unknown. So here's another example of area. Okay? Whenever you have an area problem, it's always going to have to do with the maximum area. So Ivy's planning to build an enclosure for her animals that is divided into 3 equal sections, as you see in the diagram. She's got 280 meters of fencing to use. What are the dimensions of the enclosure that will provide the maximum area? Right? So all of these, 1, 2, 3, 4, 5, 6, add up to 280. First step is we need expressions for our unknowns. And in a maximum area question, the unknowns will always be width and length, and always call width x. And then we'll calculate the length given the width. So we don't know the width, we're going to call it x. Well, if you look at the diagram, in a normal rectangle, there's only 2 widths. However, this one has 4 widths. All of these are widths, so they're all called x. Now we have to come up with an expression for the length, keeping in mind that the total amount of fencing I'm using, length and width all the way around, and then the 2 widths in the middle, is 280. Okay? How would I get an expression for one of the lengths? Well, what's the total amount of fencing I can use? 280, and then I'm going to take these away, right? So 280, and I'm going to take away 4 widths because I've already called them x. Now that represents this length and this length. So these 2 lengths together will be 280 minus 4x. How do I find just one of them? Divide by 2. That's how you find the length in this case. Which you can actually do the division. If you divide both terms up top, you get 140 minus 2x. That's an expression for the length. Now we're ready to construct a quadratic function to find the maximum area. And you must write this in here. Not doing so is a communication error. So how do I find area? Whether it's max or not, width times length, or length times width. So x times 140 minus 2x. That's a quadratic function. It's just not in the right form yet. Because remember, we're going to have to use negative b over 2a. So I'm going to multiply it through to get rid of the parentheses. And I get 140x minus 2x squared. But the x squared term is always written first, and there's a negative in front of it. Nothing in front of the 140, so we assume it's positive. And that's the maximum area in standard form. So now I'm actually ready to find the width at the maximum. How do I find x at the maximum? Well, that's the vertex. That's negative b over 2a. What's b? Looking at your quadratic function in standard form. 140. So negative 140 over 2 times negative 2 will get me 35. What does that 35 represent? It's the width at the maximum area. So I found one of the dimensions that will give the maximum area, 35 for the width. So I'm ready to write my answer. The width is 35 meters. The length, how am I going to calculate the length? $140 minus 2 times what I found to be 35. Which gives me 70 meters. And notice the question also asks, what's the actual maximum area? So I have to answer 3 things here. Well, if you know the width and length at the maximum, how do you find the area? If you know this and this, how would you find the area? Don't overthink this. Just multiply it. Which gives me what? 2,450 meters squared. Okay. So you see, you follow the same pattern every time. Same steps when you encounter these problems. For example, 4. Pistol bullet is fired vertically at an initial speed of 100 meters per second. The height in meters after t seconds is given by the formula height equals 100 times time minus 5 times time squared. Find the maximum height attained by the bullet. Well, this is actually easier than well, not easier, but required. We don't have to construct the quadratic equation here. It's given to us. We don't have to make it. Therefore, we don't have to find expressions for the unknowns, and we don't have to construct it. But I am going to put it in proper form with the squared term first. Before I can find the height at the maximum, I have to find the time that it takes to reach the maximum height. So I have to find TB, and again, that's negative b over 2a, which in this case would be negative 100 divided by 2 times negative 5. Which gives me 5. And that's 5 seconds. So what does this actually mean? It means the time it took for the bullet to reach its maximum height was 5 seconds. I actually want to find the height. How do I do that? Take t and plug it in here to calculate h. So the maximum height is going to be 100 times 5 minus 5 times 5 squared. Yep.
Negative 200 divided by negative 10b.
Oh, jeez. Sorry, I thought it was 20. That means 10. Try that again. There we go. So this is 1,000. 10 squared is 100 times 5 is 500. So 100 minus 5, 1,000 minus 500. Which is a maximum height of 500 meters. So notice we didn't have to do all the steps in that. So we've seen questions where you've been given the quadratic function and asked to find the maximum height or maximum distance or time it takes to reach the maximum. We've been given area problems where the two unknowns are always width and length, where width is always x. One more type of problem that we're going to do. And this has to do with business. So an amusement park charges $8 for admission, averages 2,000 visitors a day. A survey shows that for every $1 increase in the price of admission, 100 fewer people would visit the park. What admission cost gives the maximum revenue? First of all, what does this word mean? Revenue. Anybody? What's that? Yeah, or sales. It's the money that you take in. Okay. So don't break this down yet, but if we look at this the long way, right now, how much money are they taking in a day? Well, they charge $8, they get 2,000 visitors. They're making 16,000 a day, right? If they decided to increase the price to $9, how many visitors would they get? 1,900, because they lose 100. How much are they making if they do this?
17,100.
What's that?
17,100.
17 what? Notice they make a little bit more. So this seems like a good plan. Well, if that's a good plan, let's increase it another $1. They're going to lose another 100, but still they make $18,000 a day. They're still making more money. So it makes sense to charge $10. Does it make sense to charge even more? Who knows? But eventually, we're going to reach a point where it reaches a maximum and then it starts to come down, that the prices just become so high that there's too few visitors and they'll lose sales. The question is, what's the maximum they should charge? Okay, but we don't want to do it this way because this is very long. So here's what we do. In this kind of situation, our unknown is going to be the number of $1 increases. How many increases can we do until we reach a maximum and then it starts coming back down? So I want to find the maximum revenue. Well, how do you find the revenue for anything? How much charge times how much you sell, or how many people attend, or whatever the situation is. So we are going to need expressions for the price and number of visitors. And then I'm going to multiply those two. What's the price right now?
$8.
$8. And I'm trying to figure out how many X's can I add? And each X is $1. So that's an expression for the new price. 8 plus however many increases I can get away with. What's the number of visitors? What happens when we increase by X?
Decrease one.
Right, so every time we do an X, we lose 100. So it's minus 100X. These are what we multiply together. So it's going to be, and remember, gotta keep them in parentheses. So I get that. That's a quadratic function. It's just not in the right form yet for me to use negative b over 2a. So I got to multiply it all out, simplify and rearrange it. Well, you should know by now how many multiplications we have to do in a situation like this. We have to do 4. So we get 16,000 minus 80x plus 2,000x minus 10x squared. Nope. That's 100. I knew I did. 80x just didn't make sense. And it should be minus 100x squared. Yeah, that makes more sense. So we get, put the x squared term first, there's a negative in front of it. These two x's combine to make 1600x. And that goes next. And then the number goes last. Yeah. Wow. Thank you. It's okay, I'll catch up. All right, so now we're ready to find the number of increases that will give you the maximum, which is the x vertex. So negative b over 2a equals negative 1200 over 2 times negative 100 equals, I'll let you guys do it, I don't trust myself anymore. Thank you. So what does that mean? That means if we do 6 $1 increases, that will give us the maximum sales. Anything past 6, the sales will start to come down. So the price should be what? How much should we charge?
14.
Yeah. Price should be the original 8 plus 6 $1 increases. We should charge $14. Yes, we'll lose visitors, but it's about sales. Okay. Okay, last one, a similar one to this. A sporting goods store sells reusable sports water bottles for $4. At this price, their weekly sales are 80 items. Research says that for every $2 increase in price, the manager can expect the store to sell 10 fewer water bottles. Determine what selling price will give the maximum revenue or sales, and what will that maximum revenue be? What's my X going to be here? The number of $2 increases. And now I need expressions for the price at the maximum and the number of water bottles sold at the max. So price and number of bottles sold. And how do we get these? Well, we take the originals and then we either add or subtract. So what's the original price? $4 plus, be careful with this one, every time I do an X, how much is it going up by? 2. So it's not 4 plus X, it's 4 plus 2X. Because every time I do an X, I'm actually adding $2 to the price. How many bottles sold right now? 80. How many do I lose every time I do an X? 10. So 80 minus 10X. Those are what I multiplied on. So my max revenue, and stop it at, equals the price 4 plus 2X at the maximum times the number of water bottles sold at the maximum. And then I have to multiply all that out and rearrange it, put it in proper standard form, so I can get the X versus X. So 320 minus 40X plus 160X minus 20X squared. The squared term first, so minus 20X squared. Combine the X's and put them next, so plus 120X. And then the constant last, 320. Now I'm ready to find X at the maximum or X at the vertex. So it's going to be negative 120 divided by 2 times negative 20, which is going to give 3. Right. So the price should be what? Be careful with this one. What's the original price? Plus 3 $2 increases. So the price should be $10. How would you calculate the maximum revenue? Yeah, I mean, really what I could do is just plug it into here. So it would be 4 plus 2X, so 4 plus 2 times 3, times 80 minus 10 times 3. So that would be $10 times 50 water bottles sold. Gives me sales of $500. Okay. So you need to be familiar with max revenue problems or max sales problems, max area problems, maximum or minimum product problems that we did last time, and then questions where the The quadratic function is given to you and you just calculate from there. Okay?
So for Thursday's class,